architecture. So as of now we have discussed a lot of theory. So let's see how a typical architecture of an IoT system is. So is this slide visible to everyone? In the back? Is it visible?
Yes.
Okay. So these all are the IoT devices. So these IoT devices are connected with the gateways. So these gateways are nothing, you can think of the router of your home. So those devices which are capable or having a Wi-Fi chip can be used as a gateway. So this gateway and this IoT device we collectively call as an edge space. So these gateways will communicate with the cloud layer. So on the cloud side itself, let's first focus as a whole, then we will discuss everything. So this device, this router is going to, or this gateway is going to communicate with the cloud space, and based on this cloud space, it is going to send the command to your end user interface. So your end user interface can be a mobile application, any third party application, or any web application. So for example, you can think of, you have to turn on the light, or you have to just start your car. You say, okay, I am going to set my car, and you issue a voice command. For example, BMW, turn on my AC. So obviously your car is going to turn on before you are physically present there. So how the command will be sent from here to there? So for example, you will be using mobile app only. So from mobile app, action will be triggered. Now your car is not in the range of your mobile device. See, mobile is based on mostly these kind of technology based on BLE only. So how it is going to communicate? So it will directly send that command to the cloud. Now cloud will identify to which particular gateway it is intended for. That command will be sent to this gateway, and this gateway will try to find, okay, which particular device we have to send this command. But in case of like automotive you can see nowadays even mid-level car, for example, you can take example of MG or is garage, they have device installed. Let's move forward. So as of now we are able to control the sensors remotely. Now if we have to make this network smart, how we can do that? Because our end device is having hardly 4 or 6 KB of memory, useless kind of CPU it has. So this particular gateway has comparatively higher memory, but again not that GB of space or like Intel kind of processor. So it was decided, okay, let's start collecting all the data on the cloud, start training, model training on the cloud itself, minimize the model, and then push it back to the gateway. So now your gateway is smart enough to take actions, so that if at any point of time any sensor needs to be smart, it can be done by the gateway. So on behalf of the sensor, gateways are made smart so that they can take any action. So for example, you say, okay, I have a light bulb in my home, I have a temperature sensor in my home, and suddenly you see that your light bulb started emitting temperature reading for what it is not supposed to do. So obviously either someone is trying to hack your network or there is some anomaly in that network. So how you are going to solve this problem? So this kind of problem for network security is solved by machine learning model. So how your model should be trained? Firstly, you should collect data for all your devices. Okay, I have for example 100 devices in my network. So we will first mark as a like labeled data which kind of event can be triggered by any specific kind of device. So for example, you run it for a month data or 6 month data and you start collecting. So for example, from device D1 to D100, you know, okay, this is the capability of this device, so this device can emit these type of events. So you train a model based on that. After training it on the cloud, you minimize it, you make it capable enough that it can be run on any embedded devices, and you push that to the gateway. Now for example, your temperature sensor emitted a light event or your light bulb emitted a temperature event. So your gateway is having the knowledge that it should not make this kind of behavior. So on gateway layer itself, we are able to recognize, okay, this is a malicious event and we should take some action. Now we can make sure that if any kind of event occurs in future, so it is the onus of the model if it can directly kick out that device from the network itself. So by this way you will be able to secure your network. So like